Well, hello everybody. Welcome back to Spring Live. We are getting ready for our next talk, which is shifting to the where, exploring the path to a cloudless world. It's being brought to us by Laura. Laura, are you online? My gosh, hello there. How are you? You're
I'm
muted.
good. No, I already knew I was
Awesome.
muted. So,
Oh, I wanted to hear your voice. Teach
well,
us.
hello. Hello. Thanks everybody for joining.
Well, awesome. I'm going to turn it over to you. I am so looking forward to your talk.
I'm excited to be here. So, let me first share my screen, and we're going to do that right now. So, giving it a second to sync, and now y'all should be able to see my screen.
Looks
Yes.
fantastic.
Awesome. So, I hope you guys have been enjoying this series so far. Thanks everyone for having me. My name is Laura Santamaria, and I am a developer advocate with LogDNA. And that's probably the last time you're going to hear me mention LogDNA here. So, but if you ever have questions about LogDNA, come find me. Anyway, so I want to talk to y'all about a problem that a lot of people run into, and that's trying to understand how to take a monolithic architecture and move to a microservices framework or a serverless architecture. That's a pretty intimidating thing to go do. And it's something that a lot of people don't really know where to get started, because how do you figure out where to even consider taking your application apart and putting it all back together in a different format? So let's talk about it. We're going to dive into how to gather some data, use that data to understand how your application is put together, and really how to optimize your system for a containerized or a serverless world. We're going to start out with a little thought experiment. You're working on, let's say, a retail application, pretty tightly coupled. It's your classic monolithic architecture. And your boss comes to you and they say, hey, guess what? We want to use this new and shiny thing we keep hearing about at all the conferences, and it's called serverless. It's a serverless architecture. So we want you to go use that. And by the way, you have to get it done by next Friday, and you don't have much of a say. Well, that's a little intimidating, kind of scary to go try to figure that all out by yourself. So you need a little bit of cloud. Let's first define some terms. So what exactly are all these terms that I'm throwing around? A monolithic architecture, microservices, your serverless, containerized, which I haven't even mentioned yet. What exactly do all of them mean, so that we set a baseline before we go too much further? We'll start out with a monolithic application. So a monolithic application is a system that combines your core business logic, a user interface, maybe multiple ones, some data layers, anything that talks out to your database, APIs, pretty much all of the other aspects of an application. And it's all running on the same single stack in a tightly coupled ecosystem. So maybe your stack is running on virtual machines. Maybe you're running on bare metal servers. Sometimes maybe you're lucky and you are the single tenant on a box. While the word itself, monolithic, might sound kind of archaic or old or outdated, sometimes those monolithic applications are the best solution for a specific scenario. And you don't need to go into a microservices framework. So if it's pretty simple in terms of logic, sometimes a monolith can be a good idea. But really, probably the most popular scenario right now is people arguing for building a monolith when you're first building an application, because you want to take advantage of lower complexity, because it's all set up in one space, and you get to see how your application changes as it scales. That's pretty useful. And that's the argument that we're going to explore today, while we see how we can use our data to understand how those systems will need to change when you are ready to operate at scale and move away from a monolithic architecture to a microservices or a serverless world. So, what are microservices? What do I mean by that? Think of it more like an ecosystem. Each component of the application addresses a business need or a business function, so much so that we typically refer to the APIs in a microservices system as business-oriented APIs, or APIs defined in business terms. These services, which is why it's called a microservice architecture, they're reusable for multiple business cases. So let's say that you want to be able to use one form to update a database. Well, you can then use another form to update the same database using the same service. It's just different data. Personally, I like to call this setup a black box architecture because each service has to act just like a black box. So the data coming in and the data going out is set up just the same way. What's actually in the box doesn't really matter because it's all about the communication between all of these different little bits and pieces of your entire ecosystem. So that's microservices in a nutshell. You have some higher complexity because you have a lot more going on, but you'll be able to move a little bit faster. One example of a microservices architecture is a containerized architecture. So a containerized architecture is essentially just focusing on providing a lightweight environment for each black box that you have running. And you do that in such a way that the container can be reused or restarted with a minimal impact across the rest of the ecosystem. This is especially important for the flow of data in and across the entire system. Being able to handle those partial failures means that you need to know how can you keep all of the data safe and let it continue to flow as it needs to. I'm not really going to dig in too deeply here, as there's a lot of resources on the web that explain the different kinds of container runtimes. Suffice to say, though, there's a lot more complexity in a containerized system to consider, from failures of a container, like when you have one container fail, but everything else is running. How do you handle that? Go from there to there's a lot more pathways for the data to flow along the system as a whole. Rather than it being a linear path, as the data just kind of flows through your application and comes out on the other end, you might have the data looping back and coming from a different direction or skipping a container entirely, depending on the situation. The complexity, though, is balanced by a faster path to feature release and deployment because you already have the scaffold of the data flow mapped out. So all you have to do within each container is ensure that the incoming and the outgoing transmissions match no matter what you've done to update the container inside. Now, you have your microservices, then you get to a containerized microservices architecture. Then you can go even further and go to serverless. Serverless architectures really just go further and reduce your application down to functions that define your core business logic. This is what most people refer to as functions as a service. Now, there's other definitions of serverless out there. We're going to work off the functions as a service for this talk, but you should go look up more about serverless to understand the different areas of practice involved, like backend as a service. You really want to be able to know which one you're taking a look at when you're evaluating different services. There are some serious pros and cons to this kinds of architecture. For example, obviously you have a significantly reduced overhead when you come to operations because you're not managing servers or VMs. You also have a much smaller code base because you're really only focused on that core business logic. There's also lower complexity, which comes with the smaller code base. You have a lot less to worry about. And there's a much shorter time to deployment on features due to just how disconnected everything is. You really only care that this function just ran. You don't really care that it's coupled to 3 more functions down the line, as long as the data is flowing. There's still some drawbacks, though. Your cost of ownership is much, much higher because you're relying on infrastructure and code, the APIs that make all of these functions run. You're relying on something you don't own. So you're paying for the time and the operations expertise of someone else. In addition, you've got a lot of vendor lock-in. Most serverless setups have their own APIs, and you might find yourself writing to those APIs rather than the other way around. So vendor lock-in is a serious concern. Finally, you need to remember that this entire system is pretty much permanently stateless outside of your database. You won't really have a ton of in-process memory because these functions, they run, and then maybe you have 3 hours where it's still up and running, and then the entire system disappears, and you won't have any of that state that you just got at the end of the function that you ran. So pretty serious consideration to have on that front, especially when you think about the flow of data. But the big thing to remember about all of these different options when moving off of a monolithic architecture to a microservices or a serverless-based framework is that it's all about a shift in thought. And that shift in thought is about understanding how data flows through your system. You can think of that data flow as your business needs. Just like we talked about the business-oriented APIs of any microservices framework. But really, it's about understanding where the data is coming from, how long it needs to transform from logical step to logical step, when it needs to be held in one state and for how long, and what it needs to look like when it leaves the application. This fundamental shift in thought of how you take a look at the architecture of your application is probably what makes the shift from monolith to microservices so intimidating. Aside from just the sheer amount of work, moving from something that you understand how that architecture is put together to something that kind of flows more like a river, your data, which is always a complex situation, that's a lot to consider. So, of course, the next question really is, where do you even get started? Well, you start by understanding your application. You won't be able to just pick an architecture out of a hat and say, this is the best one. No, you need to pick an architecture that best fits your application by digging in and understanding how your application runs and how it might shift and how it might change as you try different architectures on for size. Before you get all that data, though, one of the first things you need to do is see how you can clean up your existing architecture. I can't really do a show of hands, but I'm sure most of you probably have seen that bowl of spaghetti code just kind of sitting out there where your data is moving one direction, does a complete 360, maybe hits something on the 180 side, comes back. The code bases can be really, really complex. If you're dealing with that bowl of spaghetti code, you're not really going to get very far. You really need to understand where those messes are before you even start trying to think about how to transition to a new architecture. You might not be able to fix everything, but if you know where those pitfalls are, it gets you a pretty good way down the line. Next, you need to think about what kind of application are you running? Is it back-end heavy? Is it front-end heavy? Does it do a lot of data transformation? You can get that information by pulling down everything that you have to understand how that application works. So that's obviously grabbing your code base, but it's also going on the operations side and getting your logs, getting any type of history on how the system has run in the past. Obviously also taking a look back at your Git history to see how it's changed and seeing how clients might actually interact. When I say clients, I mean customers. How customers might actually interact with the application that you're working on. Then you're going to take that gathered data and start to use it. And when I say gathered data, and I'm talking specifically about logs here, you want to go dive all the way down into trace. because you need to understand how data moves within that monolithic architecture. Because remember, this is all about understanding how data flows through your system. So you're going to use that gathered data and start categorizing different bits and pieces of your application, because you need to switch from thinking of it as these services and these modules to thinking of it as, well, what business needs are we solving? What information do I pass along from bit to bit and piece to piece? Then you're going to use that to make a map. And this is where you can start thinking in terms of, how might this someday change? The map is going to be each component of logic that you're currently running, and not business logic, logic in general. So what activities are you doing? Make those little bits and components. How does the data flow across an internal API? How does the data go from one component to another component? Does it ever go back? Does it ever skip anywhere? Understand how the data changes what you have, and use that to just build out as far of a map as you can, end to end, of what happens from point of entry to final use. Once you have a map, you're going to sit there and start identifying any communication pathways between any internal bits of logic that really meet the same business need. So if component A and component C actually meet the same business need, eventually they're going to move together into their own microservice. So you need to understand where those internal APIs are within your system and start kind of highlighting those on your map. Use the data flow to understand. If you have good logs, you probably already have this, because this is the layer underneath info, just talking about what's happening within your application. Next up, you're going to define your black box units. These are those microservices that you're thinking of. So when I was talking about component A and component C, we know that they're functioning along the same business logic, and the data that's flowing between them is flowing between them a lot. So it's going back and forth from A to C to A to C to A to C. They probably belong in the same black box. If they don't really interact with much else outside of themselves, put them all together. So you've started to understand how these core bits of unit assess a business need, how it actually answers that business need, and shapes itself already into the microservices that you're looking for. Once you've identified all of those black box units, you're then going to adjust your map. So start putting them all together, and then start seeing all of the different connections that you need to make that might be new, let's say, or maybe you need a new database schema for this one black box. You need to think about how you're going to adjust your map to add that. Do you need a new API to go in with that? How do you need to change your map based on the data that you have going in and out to start to understand where all of these different pieces fit together? Finally, after you've adjusted your map, you're probably going to see some dead ends. You're going to see new data patterns. And you need to consider how the new architecture, therefore, might trim out components. I'll give you an example. Let's say you're going into a serverless system, and you've identified that your retail application that we had from before is going to start needing to talk more to the database. So we know we have those different bits and pieces to add in. However, maybe you're not actually running some of the APIs that you were running before. So you want to prune those out. You really only need that core business logic. You probably also need your front end, but you have this core business logic, and then anything else that wasn't useful, that doesn't show that data flow, that doesn't match the new data pattern, can just get torn away. If you're following a containerized microservices architecture, for example, you might not change your database at all. Maybe you don't really need to set up a new schema. You want to keep that initial state of the application. This adjusted map, being able to prune out all of the branches, all of that information, will start to give you an idea of how to slowly step away from a monolithic architecture to the next minimum viable product. So use it. This map now is your game plan to move from point A to point Z, and you've started to map out all the bits and pieces in between. Now, you've gathered your data. You now understand how your application works and how it might change as you move from piece to piece. Before you act, though, I don't recommend just simply diving in and following that game plan and switching over. There's a lot of things you need to think about and considerations that you have. And one really, really big question you need to ask yourself and your team. And that really is this move worth it for your application? Don't go in blindly. Don't just say, hey, I want the new shiny thing of serverless, when maybe a microservices system is a better choice. Research all of this information. Make some pro and con lists and really start to understand the cost and benefit of what's going on. Now that you have a sense of how big this move is going to be, you really need to understand that there's a lot of other things going on outside of just your team and your application that you need to take into consideration. But remember, this isn't just going to fix it for you. Any change to your architecture isn't just going to be a magic wand that fixes everything you've been running into. Your company-wide ecosystem really does need to be taken into account. You're going to find cascading errors where you didn't realize that your data relies on a specific setup with a different application that's owned by a completely different team somewhere else across the business. For example, maybe you're expecting data coming in that's coded as a 500 from one application. Well, if they were to change it and suddenly start sending you 404 instead of 500, that's a bit of a problem. It's the same way on the other end. So you need to think about your own service, your own application, as its own black box as well. The data coming in and the data going out need to be the same, even if it might not necessarily make the most sense sometimes. So you need to know where those pitfalls are, where those problem points are. That's what the map really is for. And then you need to weigh whether making this switch will address the majority of those pitfalls without adversely affecting another team across the way. All of this is really, really important when you start to consider, is this move really worth it? And is my map completely accurate? You may have to go back and fix your map because you didn't think about the fact that there's data coming in from someone else and they might have changed something while you're in the middle of making this switch as you're slowly following your own game plan. That's why that data map is so important. In addition, though, you need to know your team. You need to be sure that your team will be able to support this application as it shifts from a monolith to microservices. Hopefully, your team has the ability to do that. Maybe you need to slow the process down to ensure that everyone who's involved is able to keep going and is able to help the team, help the application, and keep it up and running. Sometimes you need to think about, well, how is my team going to need to learn new skills as we take a look at this kind of a shift? So part of the data that you need to gather isn't just about the application. You need to gather data about your team too. What skills you have, what abilities you have, where you can learn from. And you might need to add that into your map as well. So there's a lot to consider here. when you take a look at moving from microservices or from a monolithic application to a microservices architecture, especially also to a serverless architecture. The data really is going to be your best guide, and it's going to give you as much information as you're going to need as you make this kind of shift. So, my biggest thing to you is to remember, you can do this. You need to ask, is the move worth it? How can you fix these big global pitfalls that you constantly are dealing with? And do you know your team? And then you need to sit there, clean up your architecture a little bit, make yourself a map, and start to understand how the data flowing across this new architecture, how the data flow is going to change from monolith to microservices or to serverless, and to start understanding all of these new paths in potentially a cloudless world. Good luck. I think there's a lot to learn here. There's a lot of information out there on the internet, and I'm more than happy to share whatever resources I can. And you can find more from me on these two websites. I'm also running something called A Minute on the Mic, so you'll see that on Twitter as well. And for that, I would now like to open up the floor for questions. I'm going to go take a look at the chat over here.
We do have a couple available.
I do. I see that.
Yes, you do. Say, would you like to understand? Mohammed, like to know. Would you like to understand the pitfalls of or the serverless with respect to data flows?
Sure. So there's a couple of different things to think about with a serverless system, and going back to talking about the stateless idea of serverless. When you have data flowing, and let's say that you're running on a system where you don't necessarily get to say how long your serverless node, I guess we could call it, you don't know how long that's going to stay up and running. So maybe normally it stays up for 3 hours, so you're able to gather some data, some transformed data from that function. But if you aren't thinking through it well, like let's say that you haven't really thought about where you can store some data in between running different functions, and you're kind of relying on that that in-process memory being there for like 10 minutes. What happens if there's suddenly a surge in usage and your plan doesn't mean that you get to keep that sticking around and suddenly you lose it, right? That's a big consideration that you need to be aware of. Another one would be that if the data coming into your function isn't exactly as you needed it, is your function going to be able to continue to manage that new data? If it's coming in, let's say it came in malformed, or it has extra data that you didn't realize that you're going to need. This is why there's this argument about using a monolithic application first and then transforming to serverless rather than starting there. Personally, I think that that switch from monolithic to serverless, when we're talking about that data flow, it has to do with how much practice you have. If you're really experienced with a serverless framework, or thinking in terms of serverless, thinking in terms of this data flow, you might not need that monolithic application to understand where your data flow might falter. But if you've never done it before, you really might need that to be able to say like, oh, hey, I didn't think about the fact that I might need that data 3 functions down the line. How do I store it? Where can I put it? That kind of information. You might not think about the fact that, oh, I didn't realize that someone else might pass me malformed data. How can I validate that before it comes in? Some of these are kind of basic considerations, but at the same time, I think there are some pretty big pitfalls too. I hope that answers your question. And if it doesn't, please leave a note. Also, where else are we here?
Also, we have another one. It says, after we've identified our data flows, is it possible that we could use both orchestration and choreography communication models at the same time for different scenarios?
That's a good question. I don't see why not. but I'm not 100% completely sure on that one. I'll be honest.
You
I
can always
guess
mark this one as it depends.
we can do it depends. I'd also say I could definitely take a look at that and maybe post up an answer on Twitter afterward. I really need to think about how you could use both of those together.
Okay.
Poke me on Twitter if I don't answer this in the next 24 hours. How about that? So, but I'll try to leave an answer somewhere on Twitter with the hashtag Spring Live. So, what else do we got? I saw one. Does serverless even make sense for stateful applications? No, not to me anyway. But some people would argue with me. They might even be on this call. But personally, I don't think so.
One question was asked, what are some best practices to keep trace of logs across different microservices?
That's a good question. So there's these wonderful log management companies that are out there that will help you keep track of all your microservices. LogDNA. No, I'm just kidding. So probably the best thing is to have essentially a place to maintain those logs. So really you're streaming them off to somewhere else when you're taking a look at microservices. And there's really 3 different layers of logs you're taking a look at. You have your operating system logs and your platform-based logs. So operating system logs, if you're running on top of a Linux box, things like that, obviously those are really nice to have and they're pretty much a given. If you then take a look at platform logs, this would be Kubernetes, maybe Heroku, stuff like that. Again, they're pretty good about making their own logs, and really streaming them all to the same place is also really, really helpful. And then you have your application logs, which requires you to write those logs well inside of your application. And so you want to be able to drive all of those to the same place. To me, that's the best practice, is getting them all to the same place, but also really, really carefully using all of your log levels so that you can definitely easily filter them, because you don't really want a ton of noise when you're trying to debug something. You just want just the information you need. So anything that allows you to stream to it, then filter it based on the information that you need in real time is probably the best practices I can think of when it comes to logging with microservices. Good question.
Awesome. We have one more. Do you have time?
Sure, absolutely.
Awesome. The biggest challenge to convince my colleagues to go for microservices is the eventual consistency. Giving up the consistency Monolithics provides. Appreciate you if you could share your experience on this topic.
Okay. So basically, what I'm getting out of this is really kind of a question about the ephemeral nature of containers, microservices, serverless, all that fun stuff. And this is really about, to me, this is about understanding how to ensure your data does have permanence. And there's a lot of solutions out there, right? Databases are one solution. You have caches, things like that, that help ensure some consistency as well. When you start getting really distributed, you obviously do also have issues with concurrency errors and other communication errors across multiple microservices. I personally don't think that is that much different than having a lot of monolithic applications that eventually all have to talk to the same database. So there's some experience there, but personally, I guess going back into that consistency, you're asking really for my experience on this topic. Mainly what I found is it really requires a lot of thinking about that architecture and, again, about the data flow. The kind of applications that I've worked on that have moved towards microservices, there have always been these pillars of consistency. That's kind of how I like to think of them. And they, in my case, they've been databases and Elasticsearch mainly. And then GitHub was our other one, but it was mainly because we were pulling a source of truth on our code bases from GitHub. But the idea is that by using the database, in our case it was Mongo, and Elasticsearch, by using those two as my pillars of consistency, I could blow away my entire application. Like, let's say my containers started falling over. I could blow away everything and rebuild and I still have everything there. Whereas I feel like sometimes with monolithic applications, it's that there's a consideration where sometimes there's data stuck in the system. There's data stuck in your monolith that if suddenly the monolith falls over, you've lost that data. Whereas a really well thought out architecture is going to send data to a permanent data store in between each one of these transactions across black boxes. I hope that makes sense. That's kind of how I would look at a well thought through microservices architecture that has some internal consistency, but also some permanence that continues to be active and be part of the system that you're looking at. I hope that makes sense.
Sure does. Well, folks, I want to thank Laura for presenting, and yay!
Thanks for having me. Yay!
Yay!